So I will talk about functions in R today. And before moving to function, there is something that we need to know here, guys. This is environments. Here we can see a place that on the very right side and upper side of our studio, you can just see the environment tab in here, this one. And R uses different environments and to store your items, guys, there, okay? And they are mainly dynamic, or they have mainly dynamic structures in there. You can just create, manipulate, or remove an environment in R. And please keep in mind that storing is just a, we are storing something in environment, but this storing is just a metaphoric verb in here. In real, environments have pointers to the local of those items in the computer's memory in there, guys, okay? So we have three kinds of environments in here. One of them is just global environment. You may see just by looking my cursor, you may see that global environment. And each object you have created so far has located in the global environment of your current R session in here. And if you just say ls, you will see I don't have anyone in my global environment so far, okay? Anytime you wanna see the items in global environments, you can just write ls in here. Also, we have package environments. In this package environments, the items of a specific package located in the corresponding package environments in here, okay? Of course, each package may include another package items too, and we can use that command to see what items in that environment in here. Let's say I want to see the package, sorry guys, I need that quotes in here, double quotes I mean, double quotes. I have package, and let's see, I want to see the ones in graphics. When I run these commands, I'm just listing all the items in that graphics package, okay? This is another environment. This is a package environment, guys. And at least, and the third of the environments I can list in here is that local or lexical environments. Each time you have called a function in R that we will do today, a new environment is created, and that's called as local or lexical environment, okay? And let's say I just generated something like this one. I have the worst year matrix, and I'm going to give the data in here. Let's say I'm just generating some data, like 2021 and COVID-19. I have cases. Let me just make uppercase, and I have a him in here. And number of row equals to 2. Let me just add them to the next line. And also number of columns, sorry guys, equals to 2 in here, okay? When I run this part, in this function, matrix is my function in here, okay? Local environment containing my data, number of row and number of column will be generated, okay? And once the function executed and completed, the local environment will be removed from there. Then you can just see university in our global environment in here, guys, together, okay? Also, we can look up the location of any function in here, just saying that environment, let's see, you want to see the location of the sequence function. When you write this one, you see that it is in base library or base package in here, okay? And also R is searching your object in the order of the following environments. If you are looking for an object in here, you see that R is just looking for that one in that order. That means it starts with the global environment and ends with the package base. It goes like that, and just checking for your item if it is there or not. Okay. If R cannot find the object in the search path, the empty environment is reached. And please keep in mind that even if it is not listed in the search path in here, the empty environment is always the final destination in here is that, okay? And so far, before moving to the functions, we have seen environments, and we just call that we have 3 environments, which is global, package, and also local environments or lexical environments in here. And we cover 3 of them and see how we can just check for the environment for one of our functions and the search function in here. And let us save the script. So after that, let me move to functions together, okay? And we have the following syntax guide in R. To define a function in here, you can just give a function, name. Here is my name. You can just give it any name you want. You are calling function in here, okay? And inside that parenthesis, I'm just giving arguments. Let's say argument 1, argument 2, argument 3, and you can just give how many you want, okay? And then we start writing any code in here to any code in here when called, okay? When you call your function, the code in here will be executed, and it is going to return your return objects. Return means your result of your function, guys, okay? Then it's going to give you that return object. This is just a pseudo code. It's not going to work, of course. And it's just an example in here to see the general structure for a function in here. And these arguments are just a set of symbol names in here. Optionally, they are just default values, okay? And they are going to be used, or they are going to be defined within the body of the function, like around here, guys, okay? And the body is an R expression. This body is going to be an R expression. And typically the body is enclosed in this curly brackets here, okay? But it does not have to be if the body is a single expression. Let's see, let me just give an example for you guys. I'm going to generate an f function in here. Here is my function. I just say I have x and y, these are my arguments, and I'm going to just find x plus y. This is just a single line, okay? It's going to work. And also I can write something like function x and y, and I can add curly brackets. It's up to me because this is just a one line of code. I can run both of them. And these are equivalent, okay? They are all the same. You can do or work with whichever you want in here. And functions can be passed as arguments to other functions, or functions can be nested. Please keep in mind that, guys, so that you can define a function inside of another function in here, okay? And the return also in here is just a value of a function, which is the last expression in the function body to be evaluated in here, guys, okay? And please also remember that a function definition in R includes the names of arguments, like in here. And optionally, it may include the default values. And if you just specify a default value for an argument, and then the argument is considered optional in here. Let's say what I mean. I have my function f. I'm going to use the second one, this guy in here. And if I just want to call this function, I should just give the name of the function as f, and I should give some values for my x and y. Then when I run this one, you see that it just run this part x plus y, okay, and return as 3. Or I can just write a g function. This is a new one. I can write x and y equals 10. 10 is the default value for my y value. And I'm just doing the same job, x plus y. When I run this one, I can only give the value of x in here as 1. Then y is 10, and it's going to return as 11, okay? And if you do not specify a default value, like in here, for an argument, and you do not specify a value when calling the function, you will get an error, guys, okay? Let's see. If I write f1, please remember that f requires 2 arguments, and it doesn't have any default value for my arguments. Arguments means x and y's for this function. And if I call f1, you get an error in f1. Argument y is missing with no default, okay? And you should just give any value for your y. Let's say I say 5, then it's going to return as 1. Also, even if you have a default value for a function in here, like y, you can rewrite or overwrite the default value. Like, let's say I want to write it as 1 and 2. And now in G, instead of 10, it works with 2 for y value. Okay. Yeah. Also, when we are talking about functions, you may specify a variable length argument list and pass extra arguments to another function, or you may want to write a function that accepts a variable number of arguments in here, guys, okay? To do that, we are going to add or use or specify the ellipsis. Ellipsis means this one. I think we talked about it before, maybe. This is ellipsis. It calls as ellipsis in the arguments or in the functions in here, okay? Let's say, let me give you an example. You create a function, okay, that prints the first argument, then passes all the other arguments to a summary function. Let's say what I mean. This is just a comment in here. We will use that ellipsis for this example, okay? We will create a function that takes one argument as x, and the argument specification also includes an ellipsis. This is ellipsis, guys, in here, to indicate that the function takes other arguments, okay? Then we will just write a function inside that one. Let's say I'm generating a v vector, which is square root of numbers from 1 to 100, okay? Here is my v as a vector with 100 elements in here, okay? I want to write a function and give it a name as my function. I start with the function in here, x, and I'm adding just ellipses in here, guys, okay? This is my ellipses in here. Let's say, in here, inside my function, I want to print x, and after that, I want to just add the summary of this one for the rest of them, okay? Here is my function in here, guys. Here is my function. And I'm going to call it as my function. I just write the summary for v, okay? And then I add v, and then with some more arguments in here, let's say digits 2. So what will happen in here is that R knows what is my function. It gets my first argument. This is my first argument, guys. Here is my first argument. What is happening with this one is that it is just printing the first argument, and the rest of them is just going inside the summary function, which are v and digits 2, okay? And when I run this guy in here, you see that the return is the summary for v is just the summary functions for my v vector, and then you see that all of them has just 2 digits in there, okay? So please notice that all the arguments after x were passed to summary in this example in here. So it's also possible, guys, to read the arguments from the variable length argument list in here. And to do that one, we will just convert the object ellipse to a list within the body of the function. Let's see what I mean. I'm going to generate a new function and give it a name as add them up. Okay, here is my function name. This is add them up. And I'm writing function in here, x and ellipses. Okay, let's see what will happen. I'm going to get them as arguments. I'm just giving it a name as arguments for the ones in ellipses, and I just convert them to a list inside my function. Okay, and for each a in this arguments in this guy, okay, I will just do x equals x plus a. Okay, here is what will happen. This is just a summation in here. I'm just summing x and a, and then for each step I will just print a in here, guys. Okay, then return x in this function. Okay, here is what's happening. I'm just reading the arguments from the variable length argument list. Okay, to do that one, I'm just converting the object to a list within the body of the function. Okay, and inside that one, it is simply just sums all its argument in here, guys. Here is my function. You need to read that one. Just run this part for R. If you change something inside your functions, you have to read that one more time, guys. Okay, please keep in mind that one. And maybe you see that in my global environments. Now I have that one named functions, and then I can easily see all my functions inside there. Okay, let me just call that one, add them up function. And let's say I'm giving 1 and 1. And it returns and 1 and 2. What's happening, it just change them to a list and give 1 the first value, and then for each step it is adding that value with a in here, and a is going from all the values that you are giving inside your function. Let's say I want to just use something like with more values in here. I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. When I just run this part, you see that it's just adding all of them, okay, and in here as my function. And there's something interesting here, guys. Add them up. If I add some like sequence in here, it's converting that one as list. Let's say I have 5, 6, and 7 to 9. And you see that for this one, I have 7, 8, 9, and just adding them with the following values in here, guys, okay? And then maybe you see that one, we are just using this function to add all these values in here, guys. So in our functions, you may use the return function to specify the value returned by the function, which is your result in there. Let's see what I mean. And I will just give you an example in here. Here is my function s. I can just say return x to the 3 plus 5. Okay. And if I write f3 in here, and it's going to give me 32, or I will simply return the last evaluated expression as the result of a function, guys, okay? And sometimes you can just omit the return statement in here. Let's say what I mean. I have my function x again, and I can even write, let me do this one. Okie dokie. I have x to the 3 plus 5, and it's just going the same job in here for me. If I just give f3 in here, it's going to return as 32. Okay. For complicated functions, of course, it's a good idea to add return in there. But if you have a simple function like one single line of code, or if you need only one single value in there, the last one is going to be your return value in here. Okay. I mean, the R just return the last evaluated expression as the result of your functions in here, guys. So I will continue with the properties of functions in here. I think it's good to know them. R includes a set of functions for getting more information about your function objects in there, guys, okay? So to see this set of arguments accepted by a function, we can use args in here, args. This is the function. Let's say I want to see the arguments in sin. Here is this function, sinus function in here. It's a trigonometric function. So the argument functions returns null value in here, okay? Because it has just this one function x. But if you have something like lm, and let's just use the same one in here. I want to see the arguments of lm function. And then now you can see that body parts in here. Here is my function. I have to add the formula, blah, blah, blah. And maybe remember that we were just using help file in here. When we just check it one, you can see that this one is just the usage of your function in here. If you just want to see the arguments in here. And so you may want to manipulate the list of arguments with R code in here, okay? And then you can just find that formals function more useful in here. So we will use that formal functions, and it will return a pair list objects with a pair for every argument, guys, in here, okay? And the name of each pair will correspond to each argument name in the function. Let's see what I mean. I want to add an example as f function. Here is my function in here, okay? I have my x, y equals to 1, which is default value, z equals to 2, and here is the body of my function. I have x plus y plus z in here, okay? Here is the f function. So if I write the formals of f, I want to just save it in somewhere, f formals. I want to say the formals of my f in here, okay? Run this part and let's see which ones are my formals. Here are the formals in here. And you see that that function just return a pair list of my objects. Here are my objects in here. And with a pair of every arguments in here. These are my arguments, these are the objects, values. And the name of each pair will correspond to each argument name in the function, which are x, y, and z in here. And when you define a default value, the corresponding value in the pair list will be set to that value in here, like 1 and 2. And if you do not give any default value like x in here, guys, you see that the value will be null or empty in here, okay? And please keep in mind that the formals function, this guy, is just available only for the functions written in R, okay? And not for built-in functions in there. You can just see this example. We are able to see the formals, and we can just use that formals on the left-hand side of an assignment statement and change the formal argument for a function. Let's say what I mean. I want to use the formals in here, just get the ones like y, okay? And I want to change it to 3. Please remember it was 1 before, and I can just change it to 3 in here, and I have to override it, okay? Formals f, and then I'm going to just write the f.formals, which are new ones. And then when you see the arguments of your f function, you see that you have x and y is 3. Now it was 1 before, and now we change it as 3, okay? This is how I am able to change the default values in a function. And there's also one way that R provides a convenience function called A-list to construct an argument list in here. And I will give an example related to that one too. So if you wanted to change the names of this function, the argument names, I mean, you can use names, f formals. Please keep in mind that formals are just giving you the formals of f. And then you can just write this like say ABC or anything you want. And then you are able to change that one, like here, okay? R just provides a list function for you to construct an argument list in here, guys, okay? And we simply specify the argument list as if you were defining a function in here, okay? Please note that if you do not have a default value for an argument, you do not need to include a value, but still need to include the equal sign in this example. Let's see what I mean. It's going to be more useful for us to work with an example for this topic. I'm going to generate an f function again, and which is, sorry guys, which is my function, and I'm writing x and y is equals to 1 and z equals to 2. Okay, here is my default values, and I'm just adding x plus y plus z again. Here is my f function. And you can just see the formals of f. Here are the formals in here. And I can use, if I want to change all of them all together, I can use a list, okay? And I say x equals, and I'm not changing that one, but I have to add that equal sign in here. Y equals 100 and z equals 200, let's say, okay? And when I change this one, guys, if you write f again, you see that instead of 1 and 2 in here, I change the default values all together by using a list function in here. Okay, and similar to that one, I can just call the body function, and it's going to give me the body of f in here. They are kind of similar, but A-list is very useful if you want to change the default values all together in here, guys, okay? Function. And like the formals function, the body function may be used, let's say on the left-hand side of an assignment statement in here. Let's say what I mean. I want to change this body function, body f, and I can just say that the expression this time is going to be like what? X times y times z, okay? Please remember the body function of my f is x plus y plus z, and I want to change this expression to x times y times z in here, okay? And when I run this part, you will see that now the body of a function has this expression which is multiplying each values of that arguments in there, okay? And please keep in mind that it has type expression in here. You have to add this one in here. So when you assign a new value, it must have the type of this expression in here. Like changing formals, you can change body of a function there, okay? It is same as writing your function one more time in here, like this one, x times y times m, but this is more professional way, okay? And these are doing the same job in there, guys. And after that one, I want to talk about the argument or order and named arguments in here. There, it's kind of like redoing everything one more time. With a more ordered way, guys, for functions in here, okay? Please keep in mind that when you specify a function in R, you assign a name to each argument in the function. You have to do that. Inside the body of the function, you can access the argument by name in here. Let's see, for example, I want to see the argument orders now. Here is my function, add the log. I'm generating a new function in here, guys. I write function, and the first one is first, and second one is second arguments for my function. And I'm just adding first to log of second one, okay? Here is my function. This function takes two arguments, first and second. Inside the body of the function, this part is the body of your function, we can refer to arguments by these names in there, okay? And when we just call a function in R, we can specify the arguments in three different ways, okay? In three different ways. You can just use exact names in here. And the arguments will be assigned to full names explicitly given in the argument list in here, guys, okay? And the full argument names are matched first. Let's see what I mean. I want to call my function in here, add the log function. Now I can use the names of my arguments in here. And let's say I'm using the second first, and this is going to be x4, and then first is 1. Here's how I'm just running my function at the log by using the names of the arguments. This is the first way to call a function, okay? And or we can partially match the names in here. R is really clever, then the arguments will be assigned to partial names explicitly given in the argument list in here. Let's see what I mean. I can just write the add the log one more time. And instead of using full names, I can say S, and I will know it is second in there. XP4, and F is 1 for the first one. And then R knows what to do, okay? Or you can use argument order, and the arguments will be assigned to names in the order in which they were given in here, guys, okay? I have add the log again. I can even write 1 and XP4, and this is the order of you are giving in here. The first one is going to be first, and second one is going to be second. When you run this one, you have the same one. Okay, this is how we can just call our functions by their names or by an order in here. Let me show you an example in here. And please remember the Fibonacci sequence, and we have used it before maybe. And we are going to use a repeat statement, okay, which is going to compute and print the Fibonacci sequence ending when it reaches a term greater than 150 in here, okay? And let me just write it from my notes. Here is what, and here is what, guys. I'm just using this repeat function. I have fib A and fib B. I'm repeating that one, and just I'm generating a sequence giving that Fibonacci, and it prints the Fibonacci sequence and ending when it reaches a term greater than 150, okay? It writes everything, and but just end when it finds 150 or greater than 150. Here is how it is going to work. I have 2, 3, 5, 8, blah, blah, blah. And when I reach a value which is greater than 150, we break there, and now we write break now in this repeat statements, okay? Now, we just going to take this Fibonacci sequence generator and turn it into a function, guys, together, okay? I want to generate a function in here. Here is how. I can say my fib, this is the name of function, and I'm going to generate a function without arguments, and I will just add the same part inside here, okay? And I run this one, and please keep in mind that the function does not use or require an argument. I don't have an argument in here. And let's call it, I'm going to call my fib function. And when I write this one, it just gets and runs my function in here and generating this Fibonacci sequence, and it stops when it finds the number which is greater than 150 and just write break now, okay? Let's assume that rather than printing a fixed set of terms in here, like 150 is just a fixed term in there, okay? You want to add an argument to control how many Fibonacci numbers are printed in here, okay? This is when a function talks, guys. And let's consider the following function in here. Please keep in mind that our job is now, rather than printing a fixed set of terms, rather than giving 150 in here, we are just adding an argument to control how many Fibonacci numbers are printed in R now, okay? I have, again, my fib2 function. I'm going to generate or write my function now, and I have one argument, which is threshold. I'm going to give a threshold in here. And I start my function. Here is the body. I will go and write this one again. Instead of 150, guys, now this time I'm going to give a threshold, okay? Here is the threshold in here. I'm just basically or easily changing that one, okay? But this one, maybe I want to just play with my numbers in here, okay? Let's say I have this one, or again, I want to add a cat function here. I have fib A, fib B, and a separator, and I repeat, and I'm just summing my fib A and fib B at each step, and that's saving it somewhere. And I cat fib again with separator, and if my fib B is greater than threshold in here, guys, I cat and just give break in here. Here's what I run this one. I have my fib2, I'm calling that one again. And let's say my threshold, which is thresh, equals 150. When I run this one, you see that I have 1, 1, 2, 3, 5, 8, blah, 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 okay? And now I can even run this one, my fib2, with, let's say, threshold as 1 million. And when I run this one, you see that it just gives me that Fibonacci number in here, okay? And then it is just writing everything on my console, and I can see it here, guys. Now, guys, we are going to use return in here, and we will use again the Fibonacci function, which is going to store the sequence in a vector and returns it, okay? Let me just get my code from my notes here. I will copy and paste my note code from here. And we are again generating a third function in here, my fib3, which is also related to Fibonacci sequence in this example. And I have my function with only one argument. The argument is just thresh, okay? And I'm having my fib sequence, which are 1, 1. And we have counter in here as, and starting from 2. And we are going to repeat these steps between the curly brackets in here. In repeats, you are getting this fib sequence and just add them to the previous one. Okay, And for each step, we have a counter in here. And I have one if statement. If fifth sequence and that value in there is greater than threshold, we just break, okay? Then we return, maybe you see that we are just saving fifth sequence in somewhere by combining the numbers in here, guys. And we are just returning this fifth sequence at the end of my function in here, okay? Let's see what will happen. Here is my function. If you want to call that one, you can just write the name of the function and give a value for threshold. This is how it is working. So here, the first line calls my fifth tree with the thresh assigned 150 in here, okay? And the output is still printed to the screen, but this isn't the result of the cat command as it was earlier, okay? When we return the object in there, guys. And we can just assign this return object, which is this one, to a variable such as foo, or just save it to somewhere. And now it is going to be another object in R in here. That means you can save the result of a function in somewhere, and that's going to be saved in global environment, and we can always manipulate it. Let's see what I mean. Now I want to use that numbers in somewhere and save them. I can just give it a name as like foo, and then I'm going to run my fifth tree function again. Let's say with 10,000, and when I run this one, and foo has the result or output of my function, okay? And maybe you see that one in your global environment as foo in here, okay? It is just a vector, and then it's just returning the values when I run my function in here. That's something very useful for you guys, okay? For example, when you write your function, you have it and you just call it in here, and you have the result in here, but you didn't save it, the result, to anything, okay? If you want to save the result of your function in here, you can just assign a name. This can be even patates, it doesn't matter. And you can, when you run the patates as your object in here, it is just providing the result of your function as an object in your global environment. Then you can use it like patates times, let's say 100. And now I have this one. Or I can just get the log values of my patates. Blah, blah, blah. It is up to you guys. You can do whatever you want now. So now I will give some examples related to return function, okay? Please keep in mind that so if we have that return statement inside that function, please keep in mind that the function will end when the last line in the body code has been run, okay? At which point it will return the most recently assigned or created object in the function. If nothing is created, such as in my fib function or in my fib2 functions from earlier, and the function just returns null there, okay? Let me just give some dummy functions for you guys to demonstrate these examples. I have my first function as dummy one. This is the name of my function. I'm just going to generate a very, very easy function in here to see what's happening. I have my A as 2.5 in my function. I have my BB as a string alone. And I have CC as string up, and I have DD as 4 to 8. This is the function. When I run this one, and when I just also run another function, let's say, or call another function, write another function as dummy2. Here is my another, oh no, guys. Here is the function. I'm going to generate another simple dummy function in here. Let's say I have again A, B, B, and C, C, and D. Let me just copy and paste this part for us. Okay. And this time I'm going to say return DD. Okay. The only difference between these two functions, which are dummy1 and dummy2, is the return statement located in the second one. Okay. I just run the first one and the second one. You see that the first function, dummy1, simply assigns 4 different objects in its lexical environment. Okay, not the global one. And you will see that I don't have any of them in my global environment. They are in lexical environment of this function. And it doesn't return anything, but in dummy2, we are just creating the same 4 objects, and we are explicitly returning the last one as DD. I have my DD in here. And if we just import and run the 2 functions, we have the same return object in here. Let's see what I mean. I have my foo as a result of my dummy1, foo, and I have my bar as a result of dummy2 function. Okay, I run this one, I have bar, I have the same result. Okay, and the only difference is just I have the DD as return, but the thing in here is that DD is the last one. Then that's why it is returning DD in 2 of them. If I say return BB in the second one, then foo and bar is different now. Okay, it depends which return are you using, and if you do not add any return statement inside your function, the last one is going to be your return in this case. Okay, and also there is something which is important in here is a function will end as soon as it evaluates a return command without executing any remaining code in the function of your function body in here. Okay, let's think another example as our third dummy function. Let's see, I copy and paste the first one and change the name as dummy3. I have the third function, and let me add return inside somewhere. Let's say I have return D or BB in here. And after BB, let's say I have return AA, okay? When I run my dummy function, let's save it to somewhere, dummy3. If I call that one, you see that I have 2.5 as AA. What happened in here is that when RC this return AA, it just stopped there and evaluate your function and didn't execute any rest of them. Please keep in mind that when you just add return anywhere, I just stop there and just give the value and doesn't run the rest of your code in your function body in here, guys. Okay. And so the dummy3 returns only the object AA because only the first instance of return is executed and the function exists immediately at that point. That's something very important for us to use return statement in a function. We have the last topic for today related to functions, which is anonymous functions in here. So functions are just objects in R, okay? They are just objects, and it is possible to create functions that do not have names in there, okay? We call them as anonymous functions, and they are usually passed as arguments to other functions in here. Let's see what I mean. I can just write, let's say, apply to 3 function, which is the name. You can just give it a name, which is a function of f, okay? And f is just getting the value of 3, oh, sorry guys, 3 in here, okay? we are just defining a function that takes another function as it is argument, and then applies that function to be the number of 3, okay? And we just call it the function apply to 3, and we just run this part, and we just call that apply to 3 with an anonymous function assigned to argument f in here, okay? As an example, let's create a simple function that takes one argument and multiplies that one with argument by 7, okay? Let's say I want to run this apply to 3 with this function of x, okay? And please keep in mind that this is taking x as argument, and then I'm just multiplying that value with 7, okay? Can you, the answer is 21 in here, guys, when I run this work. Here is how this is working. When the R interpreter evaluates the expression apply to 3 function x, this one, okay, when this evaluate this part, guys, this part in here, it assigns the argument f to the anonymous function, which is this one in here without a name, and the interpreter then begins evaluating the expression f3, okay? The interpreter assigns 3 to the argument x for the anonymous function, and finally the interpreter evaluates the expression 3 times 7 and returns the value in here, okay? And we can use these types of functions with apply functions in there. Let's say what I mean. I can just generate an A vector with some numbers like 1, 2, 3, 4, and 5. This is my A vector from 1 to 5. And I can use sapply function in here. Let's say I'm getting A. For each value in here, x, I will just get x plus 1. So you see that this is kind of a for loop. And for this sapply, what will happen is there, guys, it's getting every value of A, each of them, and getting that x value and adding 1 for each value. When I run this one, you have 2, 3, 4, 5, and 6, because you are adding 1 for each of them. Please remember that sapply just iterates like a for loop, okay? Iterates through each element in a vector. In a vector is A in here, applying another function, this is the function, to each element in the vector and returning the results in here, guys. Okay, this is how sapply function is working with an anonymous function in here. Also, it is possible to define an anonymous function and apply it directly to an argument. Let's see what I mean. I have to add in parentheses in here. I have function of x, and I can just say x plus 1 and add the value as 1. Let's see what will happen. When I run this function, the function gets the value of 1 as x in here, and just add 1 to the value I define in here. Even I say 100, then you have 101, okay? But please keep in mind that, or notice that, the function objects need to be enclosed in parentheses in here. This is because the function calls, okay, expressions of the form like f arguments, and that's why we are using this one and just adding, giving 100 inside this function in here. This is the way that you can use in here, guys. That's okay. Today, we covered functions in R with some examples. We started with environments in here which is very important for us when we are using functions in there. And then we covered functions and see some properties of functions in there, like arguments, orders, and names, and formulas in here, how to call them. and we just call the arguments by order or by names in there, and we add some arguments in here. And at the end of the day, we see some anonymous functions in here to cover all the topics for functions in R here. And this is maybe the very important topic, the most important topic in R, which is also required lots of practice. Okay, please try to practice by yourself in here.